Hi, my name is Kilian and today I'm going to be discussing with you about a theory I created on linear mathematics or linear algebra. This is what the board looks like. I'm going to explain it more in depth as we go on and explain everything. So let's start. First, a disclaimer to make is this brown thing. That is just some stuff you need to know. Even though it might sound weird, S is a variable that's going to be used a lot, and S does not equal S. So even though that doesn't sound right, yeah. So S could equal -7, it could equal 2, it could equal 0, blah, blah, blah. It could equal pi, I don't know. Okay, so first, I have to make another huge disclaimer, a few more. X equals X, of course. X with a unknown subscript does not equal X, obviously. Y equals Y, obviously. Y with an unknown subscript does not equal Y, of course. That one's pretty easy to tell. Okay, so let's start off with eigenvalues. What is an eigenvalue? So I have that right here, or I have how to compute eigenvectors and eigenvalues right here in a simplified way. So the way most people do it in a harder way, but this way is much easier. All you have to know is it's the mean plus or minus the square root of the mean squared minus the product. So that would be, let's say you have a 2 by 2 matrix, 3, 1, 1, 1. What you have to do is to find the mean, you add 3 and the numbers on the diagonal, so that's 3 and 1. I don't know if I'm still in frame. So that's the mean is 4 and the determinant is 2. So that's the product. So you do 4 plus or minus the square root of 4 squared minus 2. And I just found the eigenvalue like that. Okay, so next off, I'm going to discuss, well, I should have done this before, determinants. Right here, it might be really hard to see because that's a light color. That's just the determinant formula. Pretty easy stuff. And here is the 3 by 3 determinant formula. So you can just take a look at that. It has A1, B1, C1, A2, B2, C2, A3, B3, C3, and then how to find the determinant of that in a special strategy that I think is a lot easier to do. Okay, so that's that. And next is, I'm just jumping right to the Kilian theory here. I named it after myself. How did I find this right here is the kilicad. It is a complex shape and it is at the basis of all of Kilian theory. So how do you find the kilicad? Well, that's a good question that you definitely just asked. So the way I found it personally was I was experimenting with some system of equations, specifically that one. You can read it to yourself. And I was using Cramer's rule to find, x and y. So I was doing that. And then I noticed something. I thought to myself, well, wouldn't it be pretty funny just to draw a line between every number being multiplied by another number, whether it's a algebraic expression, just a normal constant or variable or whatever, or, product. I thought that would be pretty funny, so I did it, and I ended up with something that looked like that. And then I thought, oh, well, that has a 2 by 3, or that has 3 columns and 2 rows of dots, and it's half of a symmetrical shape. So I put the other side of the shape on, and before I get into that, I'm just noting it's important to know that in a graphing situation, 0 is the origin, and everything adjacent to it, everything is 1. So, this is the kilocad, of course. And this equation is a little bit of a doozy. It's, well, actually 4 equations with 1s on the top and bottom over every number. And these 4 equations are the equations to solve the kilocad. So they make the kilocad, okay? With me? I know you are. You just said it, I heard you. All right, so stuff. Oh yeah, before I go on, I forgot to mention on the determinant thing, I forgot to say this, but I showed the formula for how to find an inverse, which is the determinant formula over 1, or the other way around, I forgot, but something like that. So, back to this. Each thing equals 1. And also, something to say is that each equation has either 6 coefficients, constants, or variables, or it has 1 constant, or irrational number, still a constant, or it has 1, 2, 3 constants, 2 variables, and 1 product, or still a constant. So that is 6 long, but the problem with that, if I'm trying to do, I need a square matrix to do this. So what I did is I placed a 1 on both, just 6 ones on both the sides, because anything times 1, literally anything times 1 is itself. So, if you were to get into multiplying those, it would just, yeah. But those can be changed as seen there. I'll get into that later. So, since these 2 lines represent that expression is not in parentheses, it's in determinant lines. So that would be, if we're assuming x equals 1, 1 times 1 equals 1 minus 0, plus that equals 1. So that can be represented with these plus or minus these 2 determinant matrices, and so on for the 4, 1, 2, 3, 4, 1, 2, 3, 4. Each one of these represents a different part of the kilocad. And like I said before, x equals determinant s, 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 or in all the different areas. So we have to assume that x or y is equal to 1, and then whatever else is in the expression, we can add or subtract or divide or whatever you want to do to raise to the power of in the determinant parentheses, giant parentheses, by the way. And then since there's 1s all across, times 1, which is its own value. So that's, even though this looks less simple than this is indeed the simplified version of this, even though all the parentheses in there are necessary. Okay, so next is, oh wait, yeah, one thing I forgot is, before I made that, these 4 equations to make the kilocad, I had 12 equations, then I simplified it to 8, then to like 4. So yeah, that happened. So once you have this, this is the formula down here, but in determinant form. So this is 1, 1, 0, 0, 0, 1. So I actually messed up there. That should be a 0. I messed up. 1, 1, 0, 0, 0. All right, so there's all three vectors, you can add, this is the formula for turning the formula into a bunch of variables. That's a little mouthful, but you can see it and look at it and yeah, compute it and just marinate it and take it in. Now this is the formula, but instead of in equation form, it's in matrix form. And if I take the kilocad of this, matrix, I can apply the formula up here to all the rows on this, and I get the vectors 1 on I hat, 1 on j hat, 0 on I hat, for vector 1, it's 1 on I hat, 1 on j hat. For vector 2, 0 on I hat, 0 on j hat. And for vector 3, it's 0 on I hat and 1 on j hat. And if you find the dot product of all of those, it is, as specified there, 0, 0. So if you want to know the answer to the whole thing here, if the answer to the formula is 0, like in a lot of formulas. But say, I haven't written this yet because I ran out of time. Say you have something with a bunch, and I mean a bunch, of just random integers and irrational numbers. Like, I don't even know, no variables, just a crap ton of integers and irrational numbers. Well, you can still apply the same exact formula to it and get just different answers because, you know, it's not the answer to the formula. Also, the reason when I put the formula into matrix form, I keep the x's and y's, is because if I don't, the answer becomes undefined because of calculus reasons. If you know what limits are, you'd know, but I don't feel like explaining because I don't have time. And that about wraps up Kilian theory, the hottest new, well, like hottest as in like, yeah, the best new linear theory. And I'm Professor Kilian. Goodbye.
That was nice. That was a nice saying that.